Today we are going to be working on the multiplication properties of exponents. And so let's take a look at some concepts before we get into the types of problems. So the first two problems you see are going to be letters G, H, and I of this lesson. However, we need to go over some concepts before we can get to those problems. So let's take a look at what this rule is for exponents and multiplication. So you can see here we have a term 3x squared is being multiplied by 3 to the third power. So what does this mean? Well, 3 squared is the same thing as 3 times 3. 3 to the third power is 3 times 3 times 3. Well, since everything's being multiplied, these two 3's are being multiplied by these three 3's, we could rewrite this with exponents, 3 to the fifth power. So notice that all we're doing is counting up how many 3's we have. Well, the exponent tells us the number of 3's, 3 to the second power. So another way to do it is the base will stay the same. Notice that all of these numbers are still 3, and we are just counting up the exponents. So here we have 2 3's, and here we have 3 3's, and we can add those together and get a total of 5 3's. And so this is the rule we're going to end up using right here. We're going to add the exponents up on the numbers with the same base. And so when we do this, we first have to see what those exponents are. So here's another example where here we have some 5's, 5 to the fourth, 5, and 5 to the second. Well, typically we're going to add the exponents up, but we don't see an exponent here. So what would that exponent be? Well, if we don't see an exponent, it's always 1. This just means that we have 1 5. Here we have 4 5's, here we have 2 5's. So let's count them up. 5 is the base, that doesn't change, just like here, the 3's didn't change. But we have 4 5's, we have 1 5, and we have 2 5's. And we're just going to add up all those 5's and see how many that makes. Well, again, the base doesn't change, it's just the exponents. So 4 and 1 make 5, 2 more make 7. So 5 to the 7th power. Well, let's take a look at a problem. This time we have no numbers, just x's. Well, no problem. It's the same thing. So again, x is the base. That's not changing. We're just counting up how many x's we have. And so again, notice that there's no exponent on this x here, so we treat it as 1. So we count them up. We have x is our base, and we count up how many we have. Here we have 8. Here we have 7. Here we have 1, and here we have 4. And so we're just counting up the number of x's. So we have 8 and 7 make 15, 1 more makes 16, and 4 more make 20. So x to the 20th power, that would be our answer. So all it is just counting up the number of x's. Well, we've got a different scenario here on the next three problems. Here, we have x's as the base, but we have an extra number. This is called a coefficient. We've got this 3, this 2, and this 5, and they're all being multiplied. So what we're going to end up doing here is using that commutative property. So the commutative property, and if you look at the word commutative, we have that word commute in here, and commute means to move. And so what we're going to end up doing is we're going to move some of these terms around. We're going to move the terms that we can combine. It's kind of like terms, combining like terms. So same sort of thing here, except here we're multiplying. So we're going to take this coefficient of 3, this coefficient of 2, this coefficient of 5. We're going to just move the terms around. So we haven't changed the answer because we're using this commutative property, this moving property. Well, now we're going to take the x's. We got x to the 4th, we have x, and we have x to the 9th. And now we're going to use that same rule we used up here along with some multiplication. So we're going to go ahead and multiply out these numbers because they don't have a common base. You see, these are all different bases here, so we don't have to add up the exponents. We can just multiply. So when I do that, I always look to see if I can make the multiplication easier. Here, 2 times 5 is 10. 10 times 3 makes 30. So I have 30. And now I'm going to count up the exponents on these common bases. Remember, there's a 1 here for this one. So it's x to the 4th plus 1 plus 9. And I go ahead and count up all of those exponents. The 30 doesn't change. It's being multiplied by the x. And I count this up. 1 and 9 make 10, plus 4 make 14. So there's our answer. So the key is to use that commutative property, multiply the coefficients, because they don't have the same base, so we're not going to add up exponents like we did over here. And then we count up the number of x's that we had in the problem. Well, another scenario. This time we have a coefficient with a negative number, and that's okay. We're just going to rewrite those coefficients next to each other using that commutative property, and then count up the x's. So we have x to the second plus 4 plus, what number is this? 1. Well, from there we can go ahead and multiply out these numbers. So these two numbers make negative 6 times by 4 makes negative 24. And then over here we count up the number of x's. We've got 2 plus 4 makes 6, plus 1 makes 7. So negative 24x to the 7th. Well, one more example. This is just another scenario, a little different problem because we have two negatives this time. Same sort of thing though. Remember, these are just coefficients, so you're just going to bring those together using that commutative property. Negative 3 times 6 times by negative 9. And then count up the x's. Here we have x to the first, so that's a 1. Another x to the first, so that's another 1, and then x to the third makes 3. And so now we can go ahead and add those numbers up. And we can also multiply out these numbers here as well. So we have negative 3 and 6 makes a negative 18 times by negative 9. So when I do this, I'm doing 8 times 9 is 72. I carry a 7 there. And 1 times 9 is 9, plus 7 makes 16. Notice the two negatives here are going to cancel each other out because a negative times a negative makes a positive. And then I go ahead and count up how many x's I have. Here I have 1 and 1 make 2, plus 3 makes 5. So 162x to the 5th power would be the answer. So again, the key on these is take the coefficients and multiply those, count up the x's that you have remaining. Well, here's a scenario like you're going to see on the first problem on tonight's homework. Well, it's going to say write an expression for the area of each figure. So the area on these two figures is just base times height. These are both, well, they're both parallelograms. This is a special parallelogram we call a rectangle because all angles are 90 degrees. And so we're going to take those two sides, the base and the height, and we're going to multiply them. So it's just going to end up being a 3x squared multiplied by 2x. Again, because the area equals base times by height, and that's what we have here. So then from there it becomes a problem just like we were working on. So we've got this 3 and the 2 we are going to multiply together. So I'll bring those next to each other, and then I'll count up the x's. So I got x squared, and I've got another x. This makes 6x to the 3rd power. And then I guess I could go ahead and put units squared because we're dealing with an area. We don't know what the units are, so the units would just be squared. Well, we've got another problem here. Again, this is an area equals base times height. Here's our height right here, and then this is our base. The base and the height are always connected by this right angle symbol, and so that's whenever you see that, that tells us, okay, the height and the base, those two numbers need to be multiplied. Well, from there, we'll go ahead and take those numbers. We've got our 3x to the 4th that we're going to multiply by the 5x to the 6th. So we do the same sort of thing. We just take our coefficients, 3 and 5, and bring those together. And then we bring together the x's. We got x to the 4th and an x to the 6th power. Well, from there, we go ahead and multiply out those numbers, and we have a 15x to the 10th power. And that would be our answer. So 3 times 5 made the 15, and then we counted up the exponents. So 4 and 6, those add to make 10, because we have 4 x's and 6 x's make 10 x's altogether. And since we're dealing with a figure that's dealing with area, we'll write down units squared since we don't know what the units are. Well, here's a triangle. Formula for a triangle is similar to the rectangle. So we took a rectangle and we cut it in half diagonally. What we end up with are two equal triangles. And so the formula for the triangle is just base times height, just like a rectangle. But since a triangle is half of a rectangle, we're going to take this product and we're going to divide it by 2. So there's our area formula. So we've got to divide this by 2. So again, if you expanded this out, and you would end up with two shapes, and those two shapes would end up being the same size triangles. And so that's why we can just multiply the base and the height to get the area of the rectangle, but then cut it in half to find the triangle. Well, remember that important thing I told you about to figure out which is the height and which is the base is this right angle symbol. So the two sides connected by this right angle symbol are the two sides we're multiplying. So 4x times by x. And then, again, we have to cut this in half. So we're going to divide it by 2 at the end. So we go ahead and do that work. And when we combine these, there's just the number 1 out in front. So 1 times 4 just leaves me with 4. And then I count up the x's. I got 1x and 1x make 2x's. So x times x makes x squared. But then I need to cut it in half. And so when I cut it in half, we're just dealing with the coefficients here. And so when I do the 2 into 4, 2 goes into 4 2 times. So 2x squared would be my answer. So I just divided 2 into this 4. And those are units squared. And there would be our answer. So those are the first two problems you'll end up seeing on the homework. The next few problems, well, some of them are similar to what we were doing in D, E, and F, but also we're going to be dealing with some negative exponents in the next part.